Greetings, the Astro 30 here now with power. In case you're wondering what I'm talking about, today is the 11th of May and actually it's my birthday today, so happy birthday to me. And I did get a birthday present yesterday. However, it's been a pretty bad start to my birthday because we've had in southern Tasmania no power in some areas for 14 hours. The power just came back on now. I did originally shoot this intro bit here before using a work light, and yeah, well, the image would be a bit washed out, so I'm redoing it. And also thumbs up for that epic intro that I just came up with. Anyhow, on to today's little escapade. I finally received my preamplifier that I want to actually use in this amplifier project. Now it says here 10 times the preamplifier, which is incorrect, and you'll see why in a minute. Features treble, mid-range bass and volume control. Yep, okay. So if we just open it up and we can have a look at the circuit board. I've already taken this out. There's the components in a nice little box. This is the double-sided circuit board. It's about 1.5 millimeters thick. Reasonable quality, pretty much standard for these Chinese kits. Nothing really all that wonderful or great about it. However, there is an error I noticed when I was reverse engineering this a little bit last night to see what the differences in between the two circuits I've got are. Where it says right input here, that's actually the left input, and that's the right input, so they're actually reversed. I found that out because when it comes in through the right, it goes in through pin 2 of the IC here, and then eventually comes out the left output over here. So it's backwards, so we'll keep that in mind. So I'm happy to see that. That's from the same seller that supplied me with that sub-bass processor module without a circuit board, but luckily the circuit board is here. So this will be today's little project, is to build this up. But first, let's look at what I've basically reverse engineered. So this circuit we've seen before in a previous video. Now the difference between the original schematic and this one is the addition of this 47 picofarad capacitor across here, the inverting input of the op amp and the output, and that's just for frequency stabilization, and a 120 picofarad capacitor on the input. This is actually a 22k resistor here at the input on that circuit board, and a 100k feedback, so that gives us a gain of 4.5, not 10. I'm going to change it to 12 to make it a gain of 8.3. And the other change is over here we've got a 1k input impedance resistor instead of the 100k that was there on the other one. And of course still no input capacitor. This then comes out through a 1k stopping resistor like the other version, no difference there, to point A. Point A then connects to point A down here, which is the input of the band axle tone control network, where we've got a bass control, mid-range control and treble control. The component values are roughly the same, albeit these resistors here on the mid-range control are now 22k instead of 10, 7k5, 7k5, 7k5 on the bass control instead of 10. Still using a 100 nanofarad capacitor, which needs to be changed, as previously mentioned, to a 0.022 microfarad or 22N, or at least a 33 nanofarad. So, because with these changes in these resistor values here, that means that the bass boost and cut is going to be a little bit more greater than it would be if it was at 10k. Not much significantly. That goes through a inverting op amp amplifier stage, which increases the gain at each of these frequencies. Going through another 1k stopper resistor, the output capacitor, which is between 1 and 2 microfarad, and I've changed it to a 10k log pop, and then that goes out into the output of the preamp. There's no output capacitor on it. You shouldn't really need one, as the power amplifier already has one, but seeing as I've got a preamplifier output, I might want to consider putting capacitors on the RCA sockets before feeding it out, just to filter out any possible DC that might be across the volume control. So that's the schematic. I haven't had time, because I've had no power for 14 hours, to draw that out properly. I probably will before this video becomes live. I'm not sure yet. It's basically the same as the other schematic, albeit with the addition of these two capacitors here and slightly different component values in here. Not much really to speak of. So I think it's high time to crack out the soldering iron and start assembling this. And again, I'm going to do it in time lapse. Now the thing I'm going to need to do, obviously, is this has a full wave bridge rectifier on it, and I'm not going to be using that, so I'm going to need to link across two of these diodes to connect both of these inputs here, so it turns it into DC. I'm also going to have to bridge across two of the connections on each of these 15 volt regulators here, from the input to the output, so it gives you continuity from over here, because we're already running off a power supply delivering 15 volt. I'll still use the filtered capacitors provided, here, and here. They've got two sets of 100 nanofarad capacitors on the output of those regulators. I'll also include them because they provide a little bit of high frequency filtering on the line, which is good to see. And with connecting these pots, now I did come up with a solution to that, so I don't have to pass wires through the board and run the risk of, if I have to unsolder it for any reason, damaging traces or having tracks left off. I'll be using this dual inline terminal header. So it's got vertically two sets of connections there. So it's a dual inline, and I'm going to cut them down to 3 by 3. So I'll come in 3 from the right there and cut it off and solder it in our holes there. And the pin spacing is the same as the pot, so it should fit nicely in the holes. Do that for each of those connections, and then I can just solder the wires from the pots to the tops of these headers. I can't actually buy the plugs that go with this, so that's a bit of a bummer. However, yeah, let's get this set up and started, and yeah, we'll take it from there. First thing to work out would be, there's just one issue here too. This is grounded to the screws. Well, that one is. That one's not. That one's not. That one's not. But this screw is grounded, so keep that in mind when mounting it into the chassis, that it is going to earth the board. But what I was going to say is I want to work out where I need to put my wire links from the AC through to, or from the bridge rectifier. Right, there's one there. There's the other side there, so I only need that one. And that one. So that'll give me continuity from there through to there, and there through to there. Okay, so I'll need to mark which one's the link. So as you can see, what I've done here, I've just put some whiteboard markings on the bits that I need to join to make the circuit continuous from the input through to the ICs. So that would then make this connection here negative, because that should go to there. So that's the negative side here. So that'll be the negative connection, and the other side being positive and ground in the middle. So that's how I'm going to do it. Okay, that's the pre-amplifier built. Took me around about an hour, I want to say. That's about roughly right. I've got a lot of 104s or 0.1 microfarad capacitors left over. 4 went here across each diode, so they're not needed. And of course the 2 over here, so that leaves us 6. So I kept them. Now these are changed from 100 nanofarads to 22 nanofarads here in the base circuit. So all I have to do now is mount some standoffs, drill the holes in the chassis to mount the circuit board, remembering that this side is earthed, and wire up all of the potentiometers, which may prove a little bit challenging where those capacitors are, so I might just bend them sideways a little just so I can get in there. We'll see how well that situation works out. So I'm going to take a little break, maybe have a Kit Kat, a cigarette, and smoke. I already said cigarette, didn't I? Yeah. Put some standoffs on it, and yeah, we'll go from there. So next shot we'll see, it should be mounted in the power amp, in the amplifier case. That's going to take the most time to do is stripping and wiring and heat shrinking all the audio cables to solder at each of these pins. That's going to be the most time consuming. One other thing to note, notice that with this link wire here, right here near the capacitor, that joins the input and output of the positive regulator. Notice how it's standing up in the air a little. That's so it's not making contact with the center lead, which is ground, and shorting it out. I already did this during the time lapse, but we'll just double check that we've got a negative connection through to pin 4 of each IC, which we do, and positive through to pin 8 respectively, which we do. So I know that negative's up here, positive's down there, ground is in the center. And so we can hook it up to a power supply. Well, I'm going to just hook it straight up to the amplifier's power supply, I think. I'm not even going to bother with the bench power supply. And yeah, so I'll get that done. Probably take me about another hour to do that, and then we'll get into some testing. I won't wire up the audio output to the power amps just yet. We'll leave that until I have completed testing. But it's coming on. Yeah, I'm quite happy with that. Glad to have power back. So let's get on whilst we've still got power. Okay, that's all the controls soldered to the board. Bass, middle, that's the volume, and there's the treble. I've marked them with blue text, MTB, and well, volume isn't marked because that's the only pot that's different. It was relatively painless. Awkward, yes, but doable. The most time consuming part was preparing these ends with heat shrink and stuff, more than doing the soldering itself, but it's in there. So now all I've got to do is pop it in the case. I do have to remember to put 2 input capacitors on the left and right channels at the input here, or else we're not going to get much output on the scope. So what I'm going to do is I'm going to screw this in the case, put some capacitors on the input, hook it up to a source of power, which will be the amplifier's main power. I'll zip tie these controls to the top rail of the front so they're not stressing the wire too much or moving around, and then we'll get into some testing. Okay, I've got it hooked up to its power supply, turned on, and I am getting an output signal, putting 1 volt in at 1 kilohertz. As crooked as that is, I'm using the small DDS because there's just simply not enough room on the desk to have it the larger oscilloscope on there. So I'll just drop that to 2 volt per division. Now we're getting roughly 6 volt out with the volume control at full at 1 volt in. That's fine. Now if I increase the treble control, we can see the signal increases, not by much. We're looking at about 6.8 volt now, and it cuts to 5.2 center. Mid-range, yeah, we're getting roughly 10 volt out and 3 when it's cut. The bass, however, is functioning properly. We're getting 7.6. 5.2 at cut, so that appears to be working. So now I'll just check the other channel, and we also have an output at roughly the same voltage. Bass is increasing, decreasing, mid-range is increasing, decreasing, and treble is increasing, decreasing. Right, let's change the frequency to a bass frequency, so I'll change that to 60 Hertz. No, actually 160 Hertz. Now we're at 160 Hertz. Now if I increase the bass, we're getting about 13 volt out at that frequency and 1.7 at cut. So I know the bass is increasing quite significantly. Mid-range probably won't do much now. No, it doesn't. So let me change that down to 60 Hertz and see what we've got. That's at 60 Hertz. Still 10.3, 64 millivolt. So yeah, that's functioning. Now we'll try, well, I know the mid-range works at 1 kilohertz, so we'll change it to 16,000 Hertz or 16 kilohertz. Now, some of you may notice there is a discrepancy here of what it's actually reading as the frequency. Even if I change the seconds per division, no, it's actually displaying it correctly this time. When I was doing 12 kilohertz, it was saying 500.500 Hertz, which is incorrect. Anyhow, oh yes, look, there's a 23 volt 0.6 increase there when it's at full boost, and 0.3, 0.4 volt at cut. So all the tone controls are working. The mid-range again is still not going to do much, in fact nothing at all. Now 16 kilohertz is around about your typical cutoff for the human hearing. So let's change that to say 10,000 Hertz and see what we get. So again, the mid-range is not doing anything, but we've got significant increase in the treble. Okay, let's try doing a sweep and see what we get. So looking at it, with all the tone controls flat, we are getting roughly 5.5, 0.35, 27, 19. It is curving down slightly. It starts at 5.6, and as the frequency increases it starts slowly dropping off. 5.5, 5.4, 5.3, 5.2, 5.1, 5.0, 4.9. So yeah, you've got about 0.6 or 600 millivolt difference in the output signal. It is slowly shrinking. Not by much. It is relatively flat. Not quite flat. It is kind of curved a little. Now it's time to hook it up to the power amplifier and actually see what the quality of the sound is. Okay, got all Frankenstein's penis hooked up here. It's all over the place. Just making sure no wires, especially the output ones, are shorting. Now plug it in. There goes the relay. And I hear absolutely no noise on the output. Not even an annoying hiss. I can't even hear anything coming out the speakers. And that is with the volume control all the way down. So I'll turn him up a bit and I'll set the laptop's volume to full. And there we have audio. So let's just try a song. working now. Mid. Treble. No left output. I mean, no right output. There we go. Wasn't grounded properly. Brilliant. Okay, so I now know that that bass control is working as it's supposed to. So that change to a 22 nanofarad from a 100 nanofarad is mandatory. Now, I may have an issue with this treble control, that the wires may not be quite long enough to where it needs to go. I'll soon find out once I've drilled the holes. If I have to change this cable, I'll change it. It's not that difficult. That is another reason I used PCB standoffs or a header pin there, just to make it a lot easier if I have to change something without damaging the board. So let's try another track. Okay, the camera's not going to do justice to the sound of that. That sounds absolutely brilliant. The tone controls at flat sounds excellent. It's giving a nice flat response to the sound, as it should. And I'm quite happy with this particular preamp that I chose for it. And I'm so glad it came yesterday. That's my little birthday present to myself, and I'm quite pleased to see it work. And if it's your birthday today, happy birthday. As you can see, it hasn't quite been properly wired into the power amps and the power and all that sort of stuff. That's going to be in another video. I just wanted to basically test it, get it working, and make sure that it sounded okay, which it sounds absolutely brilliant. Just be aware that if you're going to power this particular module on AC, these are only rated at 25 volt, these two caps, so do not use an 18 volt transformer. I can't remember offhand if the specifications for the power input said up to 36 volt center tapped or 30 volt center tapped. I would stick at 30 volt center tapped just to be safe. That gives you around about 17-18 volt after rectification. So that's just enough for the regulators to work. Of course, I don't have them. So I can't hear any unusual hiss. That could have something to do with the choice of pot that I've got there for the volume control. Or it could just be the overall design of that particular PCB. But it works. It doesn't produce any hum or any noise of any description. The sound quality is quite crisp and clean, and yeah, I'm extremely happy with how this is coming on. So with the wiring, that'll be a topic for another video. I'll go around and wire in all the inputs, outputs, voltage rails, wire the headphone amplifier to the output of the preamp, remembering that these two inputs are reversed from their outputs. That's just a little error on the board for reasons best known to the person who designed it. Because they went right, ground, left. So I think they were just doing it when they were planning out the PCB. They just marked them the same. Who knows? Thing is, it works brilliantly. I'm very pleased. And yeah, so the next video, which will be part 12, will be to do with wiring it all up, doing the front panel hardware. I'm a little bit disappointed because on the rear panel here where it says made by Astro's Electronics Lab 2018, the labels started to bulge in the middle and stick out a bit. The rest are all okay, but only just that one. It could have been that the panel might have finally cooled down and the label shrunk or something and it's just bulged a bit, who knows. Anyway, I'm going to end this video here with a celebratory drink. Thanks for watching. See you in part 12. I'm the Astro 30, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Also, you can support me on PayPal by donating as little or as much as you want, because your donation allows me to buy stuff to play around with on the channel. And speaking of channels, check out this guy, 12 Volt Vids. He has some great content to do with electronics on his channel. Anyway, this is the Astro 30 saying see ya, have a great day.